Okay, I think maybe now we're in the recording. Alright, so side, angle, side. Triangles. Why did we use these?
We use it to find, hold on, side.
You do them to find like similarity and stuff. Isn't that when you have like one, like you'll have like parts of it, you'll have like the angle and then thing, and then you do it together.
Congruency.
Yeah.
So we did this to prove two triangles were congruent. Yes? And so instead of having all 6 pieces, all 3 angles and all 3 sides, we could have 2 sides and an included angle and prove they're congruent. Yes? What was another way we could prove triangles are congruent?
Angle, side, angle.
Angle, side, angle.
I like how you started your vowel. So, yeah. I have one.
Yes.
Angle, angle, side.
Angle, angle, side. And there was a side, side, side. Savannah is here.
Howdy.
Ooh. Welcome. Alright, so the first thing they're going to talk about, the one they're really not going to talk about very much is angle, angle, side. But we will eventually talk about it. Oh no, they do.
Like, why would they?
They do. It's just down in the bottom. So in the first green box, they just list side, angle, angle, and side, side, side. We can prove triangles congruent by those 3 ways. But there's a 4th one, which if you go down there to case 1, they give you side, angle, angle, or angle, angle, side. It's the same thing. Okay? Oblique. They say congruency and oblique triangles. What is an oblique triangle? This is chapter 7.
No sides.
No, that's not correct.
Is it like it has an acute angle? It has a non-acute. I don't know.
Okay. Oblique triangles. QUE. Do you remember in geometry when we were finding like the volume of a cylinder? Do you remember when we did stuff like that? Volume of a cylinder?
Yes.
And then if it was tilted, like the Leaning Tower of Pisa, we called it an oblique shape, an oblique cylinder. Maybe no. That's okay.
No, that just
This means it didn't sit at a right angle.
Okay.
Okay? So if we're measuring things like outside, we expect that building to come down at a right angle. We expect the walls to hit at a right angle. Oblique just means it's not. Not a right angle.
So
Okay.
if your building is oblique, that's not good.
That is not good. The Leaning Tower of Pisa is oblique. Okay, it means it does not come down at a right angle. Okay? So most of the time, if we have had,
how did they build it?
do what?
The Leaning Tower.
Well, they built it right. And then half of it sunk in the ground. So it literally
But
was
how
sinking.
is it stable enough for people to
Well, they engineered and got under there and stabilized it, but they couldn't do enough to pull it back level, I think.
So really it's not straight. It's straight.
It does not come to
just
the
the foundation
ground.
that's leaning.
Yes. The underneath, it went under the ground.
So it's not really leaning.
Wait, it still is leaning though. It's just stabilizing.
It's not leaning because
It's not continuing to lean more.
If you're standing on the slope, you're not leaning. You're still standing. You're just not straight.
No, but the
Wait.
power is leaning.
No, it's not leaning because the ground it's on
Okay.
is straight. It's
Okay,
not
my
straight.
husband's parents convinced him that goats on the side of the hill, that one side of one or shoe leg was shorter than the other, and they walked around it like that.
That's hilarious.
But he like actually believed that.
You know those goats that like
This is how.
when they get excited or scared, there's like
My parents
Those
had
are my
racing goats.
Those are my favorite.
And it was awesome to pull up to their house and honk the horn. Like half the goats would fall over.
That's so great.
It's awful.
My
I want
sister-
them so bad.
My sister works at like the, cause she goes to UC Martin, they have like all the ag stuff there. So she works in like one of the barns or whatever, and with all the goats and stuff. And they have a couple fainting goats. So she'll send me videos and she'll like scream and like
So
fall over. It's really entertaining.
It's awesome. Alright. So case one, we are only going to talk about these today. Our case one. If you know two angles and a side. If you know two angles and a side, finding the missing pieces is not really that hard. Okay? Because if you have two angles, can you find the third angle really quickly? Yes.
Yes.
Okay, so I'm going to draw some triangles. But guess what? They're not going to be right triangles, okay? So if you were pretending that that's a right angle, it's not. Okay? So don't even say it is. We're going to say it's 95 degrees.
Okay.
And this one is going to be 42 degrees. And you know, this side is 10 inches. Can you find the missing sides and angles? So here we have an angle, side, angle. Missing side, missing angle you can find pretty quick is 40, 80, 7. Oh my goodness, my brain is slowly not working.
43.
43?
Yeah, 43.
Not really drawing the scale. Okay. Now, how would you think you would go about solving for the missing sides?
Well, I would not use Pascal's formula because
I would use the sign.
The Pythagorean theorem, maybe?
right.
I would use the,
I was like, you talked about Pascal this
Yeah.
morning.
I would use the sign.
Dude, he's been on my mind.
Well.
I always think of the chameleon from Tangle.
Yeah.
Okay, may I keep my answer?
Yes.
I would use
No.
the sign formula.
The sine formula. The thing is, I already knew that you knew that because you tried to use it on something else.
So it's wrong.
No, that's exactly what
So
we're
that's
doing.
what you do. Here, you just. Hey, can I put the lid on my Sharpie? I don't want it to.
I'm sorry, that's an emergency. I thought you were.
All right. Yay, we stepped right back in like we had never left. I love it. Okay, so if this was a right triangle, if this was a right triangle, we would, what would we use?
43.
We would use a sine, and we would have an adjacent, an opposite over hypotenuse, and we would have an opposite over hypotenuse, or an opposite over adjacent, and we would use a tangent or a sine or a cosine. But is there a hypotenuse?
No.
No, there's not. So Prince is going to give us something, and I don't know if I want to take you through deriving it, but do you want to just tell it to us, or do you want to come and write it for us? So we actually learned the law of sine. Would you like a marker? No. You can't have two big A's though.
Oh, sorry, no.
That'd be a little A.
Is that made it
Oh
better?
god.
And my eraser got really small this morning.
Oh,
What is it?
why are the little dots?
It's a smiley face with a weird
It keeps
smile.
Oh yes, because you don't actually have to physically touch it.
Emily, your hair does look good.
Mhm.
Emma Evans like your haircut.
Thank you.
That's
So So what's A, what's B, what's C? Oh, we didn't write C. Could we write a C up there also, friends?
The same equation.
Yes.
With this same equation, so sine C divided by C. So there's ratios. So we're gonna have an A, B, and a C. I probably need to label that, right? Yeah.
It's not a right.
There is no right angle.
So can you do sine?
Do what?
Can you do sine?
I know what you're gonna ask me.
I already knew that we were gonna cross multiply.
We always have to cross multiply.
That's what I was gonna say, but I don't want to be wrong on the first day back.
Why?
Cause I'm wrong every other day.
No, you're not. It all has to do. If we draw a right angle here to derive it, so now the hypotenuse, if you have an angle, and what's the height going to be? Okay, so if we were to try to write equations for all of these, okay, then we would have, oh my goodness, opposite sine of 42 equals, I don't want to put it divided by sine, equals h over 10. Right? Could we have sine 43
Oh.
equals h over whatever variable this is, a? Stop. This is going to make me write big A. Equals h over a. With h's in both of them, could we set them equal to each other? Yes. So h equals sine 42 over 10. And h equals sine 43 over a. So what is h? They're the same thing. It's the same line.
Oh.
So do these two things have to be equal to each other?
Okay.
So then we set these equal to each other, and we can find out the only missing piece is letter A.
Yeah.
So then the height really doesn't matter. That's how we derive it.
Oh, that's the drew.
This is deriving it in green.
I was like,
Okay? How do we get this equation? You get it from this. Okay? So could we find what A equals? So if I did parentheses just with the equation, does everybody know that angles are big letters? Side lengths are little letters. And little a is always across from angle A. Good job, friends.
so proud. I love you.
Okay. So sine A, sine 42 over A equals sine B, which or we could use sine C, which this one is, sine 43 over 10. Is that what I just did? Yes.
I'm not
C
really sure
over
what
C.
this is.
So cross multiply, solve for A. Somewhere I wrote that off. Yeah, because I did not have them. So if you cross multiply, A times sine 43 equals 10 sine 42. And then you simply divide by sine 43.
And that's A.
Mm-hmm. So you probably do need a calculator today.
Why is it?
I'm sorry.
Good.
I thought it was going to take us a little longer to get to this point.
We're just really good.
Yeah. Print probably knew the equation. If my calculators have charged, this one's going to be. And Coach King tells you, because you did this in algebra too, probably.
I feel like I remembered.
Yeah.
I remember sign
sign.
A over sign.
I thought it would be
sign A.
Sign for the edge.
Sign A over A.
I thought it was.
Sign C over C.
I thought it was.
I think I did this one.
Listen, I thought that was H. What is here?
What about, what is H?
Why is it?
I don't want to find H ever. I don't care at all about it.
If you do A, it won't be a right. I mean, it will be a 95-degree triangle, not a 90-degree triangle.
If this dotted line is not there, that H, I don't care about. I don't ever want to find that angle, that height of that triangle, ever.
What mode are we supposed to be?
You need to be in degree mode because I gave you degrees. Okay? I don't want to find H at all. Okay? It's just a way for me to relate the angles and the sides. Okay? Just a minute. We'll do another problem, then we'll do better. But you need to know the law of sines. Sometimes, could you see this as A over sine A? I'm going to ask you a question. Are both of these proportions congruent? The top one and the second one. Are they the same? Does it matter whether I write the side length on the top and the angle on the bottom, or the angle, sine of the angle on the top and the side on the bottom? If you do them all the same, it does not matter. Because if you were to take 2 and cross multiply, either way, you're doing B times sine A, B times sine A times sine B, A times sine B. It works both ways, and they're equal. Keep sine of the angle with that side, angle A. Okay, let's do another problem. This is the law of sines. It is wonderful and it is easy. Okay? Let's be happy with knowing the law of sines. If you're given a problem, they don't even give you any problems.
Oh, jeez.
In the first little bit. Triangle that's a 32 degrees. And an 82 degrees, and a side length that is, let's say, 40 centimeters. Okay? And when I say I want you to solve the triangle, it means I want you to find all the missing pieces. I want to know, what is angle B? What is side A? And what is side B? So I usually go over and put my letters where I want to find them.
Are we going to?
Yes. Can you do this by yourself? Who needs a calculator?
Me. Thank you.
Molly, you didn't want the Lego guy that went inside the house?
Oh, I didn't see him.
He wrote the elevator down. if I checked my mode too. But that doesn't make any sense.
Is it being degree right?
Yes, you definitely need to be in degree. And if you are getting other pieces, like if you got side A or side B first, don't use it because you probably rounded. Go ahead and use 40 and sign 32 again. And then ask yourself, does your answer make sense? Is the shortest side across from the smallest angle? The longest side across from the largest angle? I know most of this you can probably just put in your calculator and never have to write down things. I would appreciate, because if you happen to be in the wrong mode, or you're in something else and you just type something in wrong, but you have the equation written down correctly, I'm more likely to give you some partial credit. Oh, I hit cosine instead of sine. Or, oh, instead of 82, I typed 28. That happens. Somebody likes to come up and write down your equations that you used.
Yeah.
Tyler, come write it down. Somebody want to come up and just tell me what angle B is?
66.
Okay, write it down. I think we all got that. You can use a pen if you want.
Oh, what? Whoa.
Yeah. It's helpful if you.
Ooh. I have one of those. Is it this one?
Yes. You're gonna write on it with your paper too, just so you know.
Oh, if you use the nail, it works
Uh-huh.
so much better.
So much better. And then you can just tell me A equals. Because you cross multiply and then divided by sine 32.
Can you do the other one too?
No. Should it have units on it? Should we round?
Yeah.
Yeah. Alright, Justin, come on up.
Yes.
Do a different color. This red starts to get a little bit.
I'll show you what. Which one do you want me to find?
Either find Big B. You've already told us what Big B was. I'll just write it up here. Is that okay? Or you want to write it up there?
So now do the BBB.
Uh-huh.
How many?
I run mine to 75.
Huh?
What did you get? 43. That's the other problem we did.
I meant 30.
32.
Yeah. Over 40, right? Mm.
Very good. So no matter what, if you have two angles and a side, you're always just going to use the law of sine.
Okay.
A little hint. If you were ever given an angle and a side opposite it, you can use the law of sine. Okay? No matter what. So the other ones, are we always guaranteed to get an angle and a side opposite it? No. Which we'll wait and do that tomorrow. Just because I don't want to start something else when we have 30 seconds left.
I like this.
I don't know.
Two angles and a side, use law of sine.